Welcome back to 6-Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today for our final installment talking about the exponent laws. 6 minutes goes by quickly, so here we go. Our key points today and the last of our exponent laws that we are going to talk about are negative exponents and fractional exponents. With a negative exponent, we will take the reciprocal of that power, but without the negative. You can see here that a to the negative m simply goes to the denominator below 1. That would be the reciprocal, becoming 1a to the m. For a fractional exponent, I use the phrase denominator becomes the index, the numerator stays the same. If I look at a to the m over n, this denominator will become my index on my root sign, and my numerator stays as my exponent. So let's see some examples. We're going to solve 4 to the power of negative 2. I have my exponent law here, and I'm going to take the reciprocal of that power, but without the negative sign. Then I would evaluate that to 1 over 4 squared is 16. How about 3 to the power of negative 5? Again, I'm going to take the reciprocal, but without the negative. And then I'm going to evaluate at 1 over 243. Let's simplify now. We have x to the power of negative 4. With my exponent law, I take the reciprocal of that power, which would be 1 over x to the 4. For a negative exponent, I like to say it just flips top to bottom or bottom to top. In this case, x to the negative 4 would be on top of an imaginary fraction, and I would move it to the bottom to get rid of that negative sign. How about y to the negative 2? In this case, my exponent is only attached to the y, meaning my x just remains as a numerator. I'm going to take the reciprocal of my y to the negative 2, which means it will go to the bottom as y squared. Please pay attention to what the base is of the specific exponent. In this case, the negative 2 is only attached to the y and not the x. Let's move on to our fractional exponents, where we will solve 8 to the power of 2/3. We have our exponent law plus our quote at the bottom. Denominator becomes the index and numerator stays the same. In this case, my denominator of 3 will become my index, and my exponent will remain the same. Now from here, it doesn't matter the order. We actually can take the cube root of 64. That will equal 4. But what we also could do is take the cube root of 8 and square that. The cube root of 8 is 2, and 2 squared is 4. 256 to the power of 1 over 4. My denominator is going to become my index. I have the 4th root of 256, and that would be to the power of 1. I take the 4th root of 256, and I would get 4 again. On to our last couple examples here. We're going to simplify x to the power of 4/5. Again, my denominator becomes my index. I will have the fifth root of x to the power of 4. Or you could also put the fifth root of x in brackets and take the fourth root power of that. Our last example here, we have 27x cubed to the power of 1/3. Now, if we think back to our previous exponent laws, each item in my brackets will get this 1/3 exponent, which ends up being a cube root. I'm going to take the cube root of 27. I'm going to multiply it by the cube root of x cubed. The cube root of 27 is 3, and the cube root of x cubed will just be x. Those are all the examples we have today for negative and fractional exponents. Please check out our Using Multiple Exponent Laws videos to get more practice using a wide variety of all the exponent laws you have learned in this series. Make sure you follow us on Instagram and TikTok at 6Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing, and until next time, keep solving and evolving.